Good morning. I want to do computation test part 2. On the first video I showed you how to change these fractions to decimals, so this time let's just do fractions. I'll be working off the back page because there's no fractions on the front. Here we go. Alright, question 8. I see 2 and 5/6 plus 1 and 4/5 plus 3 1/2. Now you're going to need to get common denominators. And how do you do common denominators? Now, you know, that's an old word and that might have been 5th grade ago. You might have forgotten. So let's go review that question real quick. You have a 6, a 5, and a 2. So I brought me some paper here to write on. So if I have a 6, a 5, and a 2, I want to skip count. Now it's probably simplest to pick the biggest number. So that's 6 times 1, 6 times 2 is 12, 6 times 3 is 18, 6 times 4 is 24, 6 times 5 is 30, 6 times 5 is 35. I'm going to stop right there. I might need more, but I might not. 5 times what is 12? Forget it. 5 times what is 18? 5 times what's... No. Okay, 30 works. Because there's a 30 in 5. What about 2? Well, I can start here because those don't work. And I can get a 30 in 2. So 6 times what was 30? 6 times 5. And 5 times what was 30? 5 times 6. And 2 times what is 30? 2 times 15. So this is going to be my common denominator. And this is how I'm going to get it. So let's go back to that paper. Question 8. So I'm going to leave that on the screen for you best I can. There we go. It looks like we got it perfect. There. So this 6 is going to be 30. This 5 is 30. And that 2 is 30. Leave those whole numbers alone for right now. They're not important just yet. And I think we said 6 times 5. So I'm going to put times 5 times 5. That's a 25. And 5 times 6 is 30. So 6 times 4 is 24. And 2 times 15 is 30. So 1 times 15 is 30. So I need to add all those numbers up, and I'm going to scoot that back up because I'm done with that other page. So 25 plus 24 plus 30. Well, 25, 24, and 30. That's going to be 9. 2 plus 2 is 4. 4 plus 3 is 7. So I have 79 over 30, and my whole number is 2, 3, 4, 5, 6. Now let's look at this number, which is like crazy number. Could I do 30 over 30 from this number? Sure I could. Could I do it again? Now that's 60. So then what's left? 60 minus 79. Yeah, you're right. How about 19? Plus the 6, because it's from over here. So this right here is your answer. Now what's 30 over 30? 1. So that's worth 1. That's 1. So I've got 6, 7, 8. And 19 over 30. Let's do another one. Question 9. Now actually, question 9 is my very, very favorite. I'd rather do question 9 than question 1. So here we go. 0 minus 3 is what? We'll stick up 0 fingers, take away 3. Yep, you've got the problem, you've noticed. How about if I borrow? Now when you borrow, you can write any number you want here, as long as it's worth $1. Why don't we do 8 over 8? You have an 8, I say let's not rock the boat, so to speak. If it's not broke, let's not fix it. I could have put 7 over 7, but then I have to get common denominators, and that's not fun. So let's just pick 8. What's 8 minus 3? 5, you're right. Bring down your 8. And when I borrow from the 7, wasn't that a 6? I should have wrote that for you. 6 minus 3 is 3. The end. Let's recap that. Add an 8 for the denominator. So I'm going to use 8 over 8, because that's a space there. It was a 0. When I borrow from the 7, I wrote a 6. I put 8 over 8. 8 minus 3 is 5. Keep your 8. And then 6 minus 3 is 3. If you're in my class, you would know Nindo. So it would be nin minus nin, numerator, and keep your dough. Let's do question 10. Question 10. I call this B plus. You're going to have to borrow, then add. So you have a 4 and a 6. You need common denominators again. And remember, you need common denominators for adding and subtracting. You can add or subtract like things. You can't take money plus a dog and get $3. Doesn't work that way. Alrighty, so let's look at 4 and 6. So if I write down a 4 and a 6, I'm going to skip count by the bigger number because it's less work. 6 times 1, 6 times 2 is 12, 6 times 3 is 18, 6 times 4 is 24, 6 times 5 is 30, 6 times 5 is 35. And you can probably do this in your head, but I'm writing it for your video. So let's count by 4s. 4, 8, 12, 16. We can probably stop though. I see a 12. And we're good. Isn't that 4 times 3? And wasn't that 6 times 2? Alrighty, we can keep working. So over here, I said 12, right? 6 times 2 is 12. And 5 times 2 is 10. 4 times 3 is 12. 3 times 3 is 9. Now go ahead and stick up 9 fingers. Yep, got them. Perfect. Now subtract 10. Yeah, you don't have one left over, do you? And no, you can't switch the order. This is subtraction. You're going to have to borrow. And you know, I think of gum. You have 5 packages of gum, and you want to give, and you have another package right here, and you want to give 9 pieces away to 10 friends. You have 10 friends, you only have 9 pieces. You can't say tough luck to the one friend. You have 5 packages you never opened. So you have 10 friends, you're going to give them the 9, you're short a piece of gum. When you open that package of gum, you're left with 4 packages you never opened. In that package of brand new gum, there was 12 pieces. Because it's a whole. Because there's 12 pieces of gum in it, and there was 12 pieces in it because it was brand new. You're giving your gum to 10 friends. You only have 9 pieces. You opened a package of gum, leaves you 4 unopened packages of gum. In that package of gum was full, 12 divided by 12. Now, how many pieces of gum do you have right now to give to friends? 9 plus 12 is, yep, you're right, 21 over 12. Now, I'm going to delete that so I can kind of not use that information. What's 21 minus 10? How about 11? And bring down your 12. And 4 packages, take away 2 packages, leaves you with 2 packages. And that one's not too bad. You just have to remember 9 minus 10 doesn't work. Let's go to the next question. Question 11. I've got multiplying with fractions. Now, you're going to need to multiply and add. Multiply, then add. Because it says fractions. It didn't say anything about mixed numbers. Good point, good point. 2 times 2 is 4, plus 1 is 5. And then 15 plus 1 is 16. So I've got, I have 5 over 2 times 16 over 3. I would probably look at factor trees to see if I can make this a little smaller, a little less work maybe. So I've got a 5 on top, a 2, I've got a 3. What's your tree for 16? And remember, I got a 3 and a 2 on the bottom. So 2 times what is 16, or 3 times what is 16? 5 times 3 is 15, so it's not the 3. What about the 2, though? Wouldn't that be 8 times 2? So 8 times 2 is 16. And I'm going to extend this. That way you have everything on top and everything on bottom. What is 2 divided by 2? 1. So when I cancel that, that's not 0. That's actually 1. And I have a 3 on the bottom. Are there any 3s in 8? 8. What times 3 is 8? No. And what about 3 for 5? 3 times what is 5? No, you're right. Nothing. So now you're going to do nin times nin, do times do. Nin times nin, do times do. And by the way, that's nin do as a numerator and denominator out. So 5 times 8, 40. And over 3. 5 was left. This was deleted. I have an 8. That's deleted. 5 times 8, 40. 2 was deleted. I have a 3. Now that's okay. It's actually correct, but you probably need it as a mixed number. So then that's 40 divided by 3. 3 goes into 4 once. Bring down your 0. And then wouldn't that be 3? Sure it would. 9, 1 left over. 13 and 1/3. Those are both correct. I like both. Let's go to question 12. Same idea with one more rule added to it. So 3 times 4 plus 3, and 8 times 1 plus 3. Isn't that always true? You multiply then add. And I'm heading that way. So 12, 13, 14, 15 over 4. The denominator's not changing. And then 8, 9, 10, 11 over 8. Now you notice I've got a divide sign here. I don't really want leftovers of remainders on top and leftover remainders on the bottom. That'd be terrible. So you're going to have to do keep, change, flip. Keep the first fraction. Change that sign to the multiplying sign. And flip this fraction over. So 11's on top, so maybe 11's on the bottom. And 8's on the bottom, so now 8's on the top. And I want to extend that line so I know the numerators and the denominators. And yeah, I know, we all like factor trees. So wouldn't that be 5 times 3? Do you have any 5s or 3s down here? So there's probably no point in doing that. What about this 8? Wouldn't that be 4 times 2? I have a 4. Let's go fish. So I have a 4 on top, I have a 4 on the bottom. 4 divided by 4 is 1, so I can do that. I have an 11 down here. I don't have any kind of number that's going to work with an 11. So let's multiply. 15 times 2. 30. 11. That answer's okay. And if you divided, 11 times 3 is 33, and that's terrible. So 22, how about 8 left over? So 2 and 8 11ths. And that's okay also. Alrighty, I hope you enjoyed my fraction lessons. Do you need help with those integers? Maybe we should look at that. Let's look at that. I first want to do all the multiplying dividing. Why? Because they're easier. So let's look for them. That's subtracting. Nope. That one is. I want to go there. No. That's not multiplying dividing. Those parentheses mean that's a negative. That one I like. I like that one. And that's too bad. I only got 3 I like. Remember, I'm making those smiley faces with multiply and divide. So multiply, divide. We're doing those smiley faces. That's the only, it's at the bottom, sorry. There's my key. So multiply and divide, I'm doing this little froggy smiley faces. Okay, 15 divided by 5 is 3. That's a half a frog, said the frog. It was a bad day for him. Another version. If it's odd, it's going to be negative. If it's even, it'll be positive. You have one negative. That's odd. It's negative. Let's look at this one over here. What's 18 divided by 6? Okay, that's 3. There's my smiley face sideways. So it's positive. And there's 2 of them, so it's positive. So you can do smiley face, or you could do an odd count is negative, an even count is positive. Whichever one you remember. I don't care. And I think, oh, this one here. 6 times 8 is 48. But I only have one little negative, so it's negative. Alright, let's do another group. So I've got those done, and I like those the most. They're the easiest. Let's go with the adding ones. That's for sure, because the subtraction ones are the worst. Here we go. Isn't that same sign add and keep, different sign subtract? Negative, that's positive. They're different signs subtract. So 14 minus 8 is 6. Keep the sign of the bigger number, this one, and then you'll be exact. Same sign add and keep, different signs subtract. Negative, negative. Looks same to me. Same sign add them. That's 18. Keep the sign of the bigger number. Doesn't matter, they're both negative. Do we have any more adding? I don't think so. And I think I'm done with this side. I am. So let's move back over here. Looks like to me you got lots of subtract signs. You got some that are just basic, and then you got the doubles. Let's just go to this one. Why don't we just stick in an add sign, and now we're good to go. So you got same sign add and keep, different signs subtract. Well, that one's negative, and yes, you're right, that one's negative too. So they're both the same. They're both negative. Same sign add and keep. So how about negative 11? For sure. Now let's go to these other two. We talked about that in class with markers. You're going to take these two, stick them together, and make an add sign. So now you have negative 7 plus 3. Negative 7 plus 3. And it might be easier to look at it if you rewrite it. So again, same sign add and keep, different signs subtract. Positive, negative, different. Subtract is 4. That one's bigger, negative 4. And lie down here. Put them together, make an add sign. That's 2 plus 8. Well, that one's 10. That's elementary. Alrighty, hope you enjoyed the video. Reminder, you can't do subtract sign with same sign add and keep. It has to have an add sign, and you've got to fix that before you even start. Alrighty, enjoy. Good night.